Good morning all, I'm Nicolas Germain, I work at France Energy Marine and I'm responsible for the R&D program Re-Architecture and Network Integration. I will give a short presentation about farm-level design tools at France Energy Marine to provide a context around those design tools and what is expected from our understanding by the industry. I will speak about the project at France Energy Marine, about design tools, and give a focus on user needs and expectations. Well, so in this first slide, I have gathered a few schemas representing the design process of several existing tools. And this is to introduce what is a design process at the farm level. So I will give a few explanation about the left-hand side of the screen, the picture showing the process of the Deterioration tool. Deterioration is a European project. I will speak a bit more about it later. There has been a first European project about it a few years ago in which France Energy Marine was involved, which has led to the definition of first generation tools, which can be seen here. It's a sequential design process, meaning several disciplines are optimized one after each other. Disciplines with associated physical model you can see on the top of the schema in green. 5 of them are included. I will give a few description of it. First, the layout is defined, our hydrodynamic, it's named here, and the machine will be placed so as to harvest the maximum possible energy and minimize wake losses. Second, optimized discipline is electrical topology and subsystems, so designing the interior cable, export cable, and substation. Then mooring and foundation system are designed, and lastly, everything about logistic is being designed. So here it's split in two modules: installation and operation and maintenance. So you can see that this is an iterative process at each with optimization algorithm for each discipline. Other tools rely on, for instance, one optimized discipline, and if you want to produce the most classical KPI, which is cost of energy, LCOE, then you have to use cost functions to add the financial dimension to your results. So cost functions are analytical, most often empirical based function to put some figures on the cost. So I will speak about two projects, as I said. The Valerie project first, and then the Deterioration Plus. We can mention two other projects at FEM that can be linked to the farm level, which are Moses and Dynamo, two projects dealing with just awarded and dealing with monitoring, the first of the floating substation and the second one of dynamic cable. Both of them have farm level dimension. So I will give you a few words about Valerie result. Valerie is a 1-year project that is finished now, which has been about defining the perspective, the needs for design tools. So what has been done? First, we have made a functional analysis to back our work, so to work on a single base. We have done an extensive state-of-art of existing optimization models and optimization software and codes, and also about the numerous disciplines that can be designed, optimized, and trying to identify for each discipline the various fidelity level existing for each discipline. It's exemplified on the top right of the picture, where we can see 3 radar graphs. Each graph represents one optimization, one designing tool, and each branch of the radar is one discipline. And the farther you are from the center, the most refined, the highest fidelity level you have for this discipline. Meaning, for each branch, there are several models that can be that are defined along this branch for one discipline. Meaning, the greater the area of your radar graph, the more discipline you have, and the finer representation of those discipline you have in your software. So we did this for a variety of software, and this is a good representation of our state-of-art results. We also developed our own AEP module based on Deterioration, which is a tool dedicated to ocean energy. We have used it for wind optimization, so we have done this, and this is what is shown in the center picture, the reddish one, some overlapping wakes. So we also did some benchmark comparison between softwares, mainly layout optimization, and this is the bottom picture on which you can see a comparison of 4 layouts for the same condition, exact same inputs, almost same inputs. And for 4 different software, the bottom right one being Deterioration, the module we have adapted to wind energy, and the 3 other one are commercial software, namely WindPro, OpenWind, and Wind Farm Analyst. So the comparison has been a bit hard to make some conclusion on it, since I mentioned same exact inputs, but actually there are some tune parameters inside software we are not able to identify, so comparison has been made. The results are fairly in a fairly reasonable similar results, but some discrepancies could not be explained based on those difficulty to access parameters. A user need consultation has been done, online poll, and the perspective have been derived based on a gap analysis between the benchmark results and the user need consultation. I will give a few more details about the functional analysis, which is an original piece of work we did in this project, and which is backing all the methods used. So we have largely inspired our work on an article from Babarit et al., stakeholder requirement for commercially successful wave energy converter farms. So we did this for offshore renewable energy design tools, meaning we've been a bit more open to energy conversions technologies, and the biggest chance is to switch from the farm system to the design tool system. So the method from this article that we have used relies on 2 concepts. Capabilities, it is what the system must be, passive description of what it is, and the function, which are how the system answer, what the system do to fulfill the needs, the capabilities. To define those 2 sets of capabilities and function, you have to define the goal, main goal you want to achieve, which is the mission statement. It's called like that. And for our design tool, this mission statement is the marine renewable energy farm optimization tool allows the relevant stakeholders to comprehensively make informed decisions on the design of the complete marine renewable energy farm system, meaning accounting for all subsystems and stages across the farm life cycle at any stage of the farm life, in order for the future or existing farm to optimally convert energy to electricity and deliver it to the continental grid market in a competitive and acceptable manner across the farm life cycle. So it's a bit long, but you have to put all objective in your mission statement. You want the design tool to do. So the next step for this functional analysis has been to derive those capabilities and function. It's an iterative process. This one not automated. You have to make some brainstorming and workshops to derive all the needs that are final description of the mission statement and the function answering those needs. So here is presented the first level of capabilities and function, having in mind that 3 sub-levels exist for each one. If we go through the function, we can see that the three first one describe more or less a method. They are quite basic at this level. The first one being to define the modeling of the farm, what you want to model at which level of complexity, which stages of the life cycle you want to include in your design process, at which stage of the design process you are. The second function is really to optimize which algorithm, which method, and so on. And the last function of the method itself is to help the decision-making process. The last function, F4, is actually to switch from a method to, let's say, something more material. So provide a software solution platform for your tool. The result of which are the matrix you can see with crosses at the correspondences between capabilities and function. There is also a really biggest matrix which details how every function answers the capability. Of course, several functions are needed to answer one capability, and one function can answer several capabilities. There is no exclusive matching. Another last result we have about this functional analysis has been a tentative definition of criteria and associated score, so as to be able to evaluate your tools. So for each match between capability and the function, we have defined some criteria and some threshold to evaluate your tool. Unfortunately, we have not been able to exploit this whole evaluation methodology for our benchmarking exercise. We ran out of time, so it would be nice to present those tentative criteria and refine them and to try to use them for real softwares. Now we speak a bit about the Deterioration project. Deterioration is the second generation of open source design tool for wave and tidal energy converters. The project has been designed like this. First, the specification of the tool, what is needed. Then development phase of the four tools and submodules that I will describe a bit more after. And then a big part, as big as the coding one, is integration and an evaluation against a real-world scenario in order to reach TRL6 for the software. And other activities are linked to market analysis of the ocean energy market and a business plan for such tools being developed. So we have a video of this presenting the four design tools. So Deterioration is a suite of tools for the selection, development, and deployment of ocean energy system. So there are four tools inside this one to help you validate stage by stage your project. So the first one is structured innovation. It allows you to identify a new innovative concept worthy for further development. So it is really useful, and it is mainly used for a component or subsystem identification. The second tool is a stage gate tool, which is really useful to help you evaluating the current development stage of a technology you are proposing and identify further action needed to reach the next stage of development. Then you have the deployment and assessment tools, which are numerous. Deployment tools are site characterization to define the environmental loads and that your farm will see. Energy capture is layout optimization. Energy transformation is about power takeoff. Energy delivery is, as already mentioned, electrical topology. Station keeping is also mentioned in Deterioration 1, and mooring, anchoring, and foundation. And the last one is about logistic marine operation for installation, operation, maintenance, and decommissioning. You have also 4 assessment modules, performance and energy yield, to derive your AEP and associated losses. Lifetime cost is to put some figures in euros or dollars against your project to derive the cost of energy. The next module is reliability, availability, maintainability, and survivability. So really based on reliability assessment. And the last one is environmental and social acceptance, which pressure your farm are producing on the environment. There is a dedicated talk about this module. The module in bold underlined are developed by France Énergie Marine. So the main, now I go to user needs, which have been identified in Deterioration Plus, which are those main findings, classically about software speed. Fast calculation at the concept definition stage are expected. More details are expected for later stages of development, because in deterioration, 3 levels of fidelity, 3 different levels of complexity are defined in the tool for each discipline. Users expect to spend between 3 to 14 days in designing, in building the model before running them, because data gathering and model construction can be really time-consuming job. From the software perspective, what is expected as characteristics: usability, followed by flexibility and expandability, and lastly modularity, where the quality, the software qualities are most expected by user. Important point also is transparency. How the tool works is critical, and which literature and what is the background for the research that back your method and the algorithm. Various levels of fidelity that were proposed were seen as complex to handle in a tool, but useful when you have a project developer, for instance, going through various stages. It's useful to use the same tool for data flow, for instance. And also what has been really asked by user is to have a seamless transition between the various modules and the stages of the tool. Now I will say a few words about Valerie results. Here, as bottom left, are population that has answered the poll we did, and the other 2 tables are results of user needs and perspective. Perspective being the gap analysis between user need and the benchmark exercise. I will speak about the 4 main perspectives that has been identified in Valerie. The first one being decision aiding functionalities. We are dealing with complex system, as mentioned, and this is really something asked by user. Second, and in a different way, so could be almost rank first equal, is a joint optimization. As we've seen, sequential optimization is a classical approach, and joint optimization seeking for a global optimum, meaning optimizing several disciplines at the same time, are really expected to be developed in the coming years. Multi-objective optimization is also something expected in order to provide with more results, not only the LCOE, but cost and performance against the same shown on the same graph, for instance, to help in decision making. And finally, but linked to the 3 first perspective, global methodology, which optimization scheme to use, joint, sequential, which discipline first. If I go to joint optimization, to which level of fidelity can I go? And subject like this. So in overall, to sum up about recommendation and tool expectation by the industry, What we can see is actual methods are mainly sequential and developed internally by project developers. So there are some confidentiality issues, and there is no applied method and associated tool existing to our knowledge, including many disciplines. We see that the problem is really complex, as is well emphasized by the large number of modules developed within the Deterioration Plus project, for instance. We can say that academic work exists and research center work a lot on joint optimization solution. And there is a growing interest of industrial about such method, both from project developer and the commercial software developer too. So things are moving. A few words about floating offshore wind technology. We have seen no tool including several disciplines for this. So a good start we would like to see is a joint optimization, scheme optimization tool with AEP-based design, electrical topology, mooring system design, the three of which designed jointly, and on top of which we would like to see environmental impact evaluation. So, and lastly, a global methodology would be very welcome by the industry. So, thank you for your attention. And now we can proceed to the next presentation. Thank you.